Hello students, today we will start with a chapter that is energy for standard 8. Now in this we will see what is work. Now in physics, work has a different meaning. Okay, it has a special meaning. Now when is work said to be done? Work is said to be done when a force acts on it, on a body, and the body is displaced from its position or it is set into motion. Work is said to be not done when the body does not change its position even after the application of force. Okay, so we see few examples of work done. Now, a boy climbs up the stairs. That is one example of work done. Then a person pedaling a cycle. In that case also work is said to be done. Then the horse pulling the carts. In that case also work is said to be done. Now work is not done even after the application of force. We'll see few examples for that. When is work said to be not done even after the application of force? Now the first example here is if a person tries to push a wall. He tries to put a force on the wall and tries to push the wall, but the wall does not move. The person gets tired, but still the wall does not move. In this case, no work is said to be done. Similarly, if he tries pushing a car and it does not move. The third example is of a pulley lifting a luggage and keeping on his head. Now in this case, when the luggage is being lifted from the ground level and it is being held up on the head, the work is said to be done. But if the pulley is just standing with a load on his head, then no work is said to be done. Now work is done when a force is applied on it and if there is change in the shape and size of the object. So if there is a change in shape and size of the object, then we say that work is done. So for this we take an example of a rubber band. Now if we take a rubber band and we try to stretch the rubber band. Now in doing so, we are applying a force in stretching the rubber band. So when the rubber band is stretched, there is a change in the size of the rubber band. So in this case, work is said to be done. Similarly, if I take a toothpaste tube and try to squeeze it. So in squeezing, there is force applied on the tube and there is a change in shape of the tube. In such a case, work is said to be done. Now, moving on to the conditions which should be fulfilled for the work to be done. Now, the conditions for work to be done. Now, for the work to be done, it should fulfill two conditions. Now, first one is a force should be applied on a body. A force should be applied. Okay, a force should be applied on the body or an object. And second condition is the object should produce a motion. An object or the body produces motion or there is change in the shape and size of the object. Right? So these two conditions should be fulfilled for work to be done. The first condition is a force should be applied on the body, and the second condition is motion should be produced in the body or the object should move or the shape and size of the object is changed. Okay, so now moving on to the factors affecting the amount of work done. Okay, now moving on to the factors affecting the amount of work done. Okay, so we see the factors affecting the amount of work done. Now the first factor which affects the amount of work done is the magnitude of the force applied. The magnitude of the force applied. And the second factor is the body should move a particular distance, or it should move a distance in the direction of the force. And the body and the distance moved by the body in the direction of the force. In the direction of the force, right? So now here we have seen the conditions for which the work should be. Now these two conditions should be fulfilled for the work to be done, and now we have seen the factors affecting the amount of work done. So our first factor is the magnitude of the force which is applied and the distance moved by the body in the direction of the force. Now we will see the dependence of the factors, both the factors, on the amount of work done, right? So now my first factor is dependence of the magnitude of the force on the amount of work done. Now, more the magnitude of the force, more is the work done. Now we can take an example to understand this. Now if I try to lift an empty bucket, I require less force, but if I want to lift a bucket full of water, right, it requires more force. So more the magnitude of the force, more is the amount of work done. Now the second is dependence of the distance moved by the object in the direction of the force. How it depends on the amount of work done. Now more the distance covered by the object or the body which moves in the direction of the force, more is the amount of work done. For this we take an example. Now if a person climbs the stairs from the ground floor to the first floor, so he requires more energy to climb from the ground floor to the first floor, and still more energy to climb the stairs from the ground floor to the second floor, which explains the dependence of more the distance, more is the amount of work done in the direction of the force. Now moving on to the next topic, that is the definition of work. Now how is work defined? Now what is work? Now work done is the work done on a body by the force is the product of force applied and the distance it moves in the direction of the force, Okay, so this is the definition of work done, that is definition of work done. So now, what is work done? Now, work done on a body by a force is the product of force applied and the distance it moves in the direction of the force. So now, if I have an object which is at position A, okay, I have an object which is at position A and I apply a force on the object. So the object gets displaced to a position B, right? It gets displaced to the position B. Now the distance from which it has covered from A to B is equal to, that is D. Okay, so the object has moved from position A to position B. So here there is a force which is applied on it and the object has moved to a distance, that is position B. So work done is equal to the product of force into displacement, that is distance D, in the direction of the force. Right? Now when is work said to be 0? Okay, now if force is applied on the body but it does not move or it does not change its position, so in that case D is equal to 0. So work done is also equal to 0. Now moving on to the unit of force. Now we derive the unit of force over here. So unit of force here is unit of force. Okay, we have work done is equal to force into distance, F into D. So the unit of force is measured in newtons and the distance is taken in meter. So the SI unit of force is Newton meter. So SI unit of force is Newton meter and this has been named after the scientist, that is James Prescott Joule. Right? Now Newton meter is also written as Joule. Okay, and the symbol for that is J. Newton meter. So work is also written in joules and the symbol for it is J. Right? Now moving on to what is 1 joule. Okay, we will see what is 1 joule. Now 1 joule is equal to 1 Newton. 1 Newton into 1 joule is equal to 1 Newton into 1 meter. Now how do we say 1 joule of work is done? Now 1 joule of work is done by a body when a force of 1 Newton acts on the body and moves it by a distance of 1 meter in the direction of the force. So what is 1 joule? So 1 joule of work is said to be done by a body when a 1 Newton force acts on the body and the body moves by 1 meter in the direction of the force. Right? Now we have seen the units, that is joule. This is the smaller unit. Now the bigger units of work is kilojoules and megajoules. Okay? So we have kilojoule and megajoule. Right? So we have kilojoule. So 1 kilojoule is equal to 1000 joules and 1 megajoule is equal to 10 raised to 6 joules. Now moving on to, now if we measure the force in kgf, if the force is measured in kgf, right, and the distance is measured in meters, right, the distance is measured in meters, then the unit of work is kgf meter. kgf meter. So 1 kgf meter, 1 kgf meter is equal to 9.8 newtons. Okay, it is 9.8 newtons. Now if I take here, that is meter. So 1 kgf is equal to 9.8 newtons. So 1 kgf meter is equal to 9.8 newton meter, which is equal to 9.8 joules.